So I forgot a couple examples to go with example one. So here we're still on example one. Let's continue on with them though. Uh, so we're going to come back and remember we've got inverse variation. That's either where the product of x and y is constant or y equals the constant divided by x. For direct variation, it's the division that is constant or y equals kx. So you're trying to get it to match one of these two forms. Um, and at first, for C, well, it almost looks like direct variation, but it's not a y equals x. It's a x equals 2y. Well, that's still a direct variation. If I divide both sides by 2, I have x over 2 equals y. But x over 2 is the same as 1 half times x equals y. And that is a direct variation. And your justification could just be the equation itself there. It's in the direct variation form. Maybe rewrite it so that it's y equals 1 half x. But that's not too big of a deal. I want to adjust my 1 half there. There we go. All right. For D, here I notice I have the product of x and y, which makes me think inverse variation, but it doesn't equal a solid number. But again, if I can divide both sides here by a coefficient of 2, I get xy equals 5. So this would be inverse variation. Again, you could just write the equation down there as your explanation. Now I'm just going to keep on going to example number 2 here. For this kind of problem, we're going to be, there's a step here. So we're going to try to write an inverse variation. Here's how it usually goes. They give us a condition for the variation. After we figure out what that condition is, we're going to solve for k, the constant of variation. Then plug that k value back into the form. Now, there's one step that we'll do later on with this. We're going to calculate a new condition. So, here, let's do the first 3 steps. So that's what this problem's about. Assume that y varies inversely as x. So when you see that phrase, and yes, as is the correct word there, that immediately should tell you yx equals k. That's what you're going to be using. It then gives you a condition. That's the blue part here. Y equals 18 when x equals 2. So it's telling you at one point in the relationship when it is an inverse variation. So we're going to plug that in and solve for k. So I have y is 18, x is 2, and that's going to be my k value, which is nicely 36 equals k. The last part here, so we'll mark that with the green one there. The last part here, we're going to write the inverse variation. That's the third step here, where we plug that k value back into the original. Yx equals 36. Or you could write y equals 36 over x. Either one of those would work just fine. They're the same thing. Okay, now that's what you would normally do there. The last part, which we'll come into later, they're gonna say like when y equals some number, and all you got to do is plug it into the relationship and figure out what x is. But we'll do that later.